Good afternoon, everyone. Today we're going to simplify a few radicals. So for the first one, we have the square root of 80. And the square root means we're going to look for factors of 80 that are perfect squares themselves. So if you think of what those might be, you might come up with 4 and 20, where 4 would be a perfect square, and that'll work. We can do that. We can do 4 times 20. And now by the properties of exponents, that also apply to radicals, because radicals are really just exponents, right? The square root of 80 is really 80 to the power of 1/2, right? So, by one of the exponent laws that we've covered in grade 9, we can write this as two separate square roots multiplied together. And now the square root of 4 is just 2. So we can write this as 2 root 20. And now we can redo this process with 20 because 20 has a factor that is itself a perfect square, namely 4. So we can write this as 2 square root of, again, 20 becomes 4 times 5. And then the same thing we did here, we're going to split the product under the square root into a product of square roots, right? So we'll have 2 times the square root of 4 times the square root of 5, right? Applying the square root to each of the products, to each of the factors, rather. And now we have 2 times the square root of 4, which is 2 times 2, times the square root of 5, and 2 times 2 is 4, so we have 4 square root of 5, okay? We can get there a bit faster if we recognize that 80 also has a factor of 16 that is a bigger perfect square, right? We can write 80 as the product of 16 and 5, which we can now write as the product of the square root of 16 times the square root of 5, which is just 4 root 5. So we get there a bit faster if we recognize an even greater, an even bigger perfect square that is also a factor of 80. Okay? So we're always looking for the biggest factor that is a perfect square. Or in this case, when we have a cube root, we're looking for the biggest factor of 56 that is a perfect cube, right? Now, you can take a second to think of what that might be, but you'll eventually come to 8 times 7 because 8 is a perfect cube. It's 2 cubed, right? So we can write this as the cube root of 8 times 7. And now, using the same exponent law as we did with the square root, the same applies to cube roots, fourth roots, so on and so forth. So we can write this as the product of cube roots, namely the cube root of 8 times the cube root of 7. And the cube root of 8 is 2 because 2 cubed is 8. And so we get 2 times the cube root of 7 is an irrational number, so we leave it as a radical. A radical is any value that has a root symbol inside of it. And so we write this as 2 times the cube root of 7. And we're done. Okay? Hope this helps. Thanks for watching.